might see more of the rain and more Monday, Tuesday, I think. From what I can see from the forecast. So, yeah, a bit more wind Monday, I think it's Monday, Tuesday. And then away, it drops away again. So, get a fairly nice night here in T-Tuma Harbour. And, yeah, full sun around the boats. 1, 2, 3, 4, 5, 6. Yep, not many. And there's nice and sheltered on here from the southwest, which has got a bit more to the south, I think. So, I can see in here. And we're going to move around to Coromandel Harbour a bit later on in the day. Going to go ashore, I think, tomorrow morning. On the tide. So that's all we on that trip. Don't activity video.
So obviously a PC interface is nice if you've got a big screen and plenty of power, but we did also want to recreate the mobile control box, which was never issued with the kit. And so we designed this board 2012, I believe. We actually did this work, and as you can see, I get on very quickly with my jobs. So this is the heart of the controller. We have a PIC chip 16F877A, which monitors a 4x4 keypad. It gives us RS232 comms, sorry, yep, RS232 comms, a display, and an interface to the audio board, because the audio coming out the receiver is actually at detector level, it's not loud. And then the audio board looks like this. So we've got a bridge amplifier. In fact, we changed this later on to be dual channel, because the receiver is capable of ISB, i.e. independent sideband receive, where you can have different traffic in each sideband. But again, it's an audio amplifier with some gates, some CMOS gates to switch the audio in and out. It's got PWM coming from the processor to inject tones, and an interface to the processor. And the implementation of that looks like this. It's a homemade PCB. So there's our microprocessor, RS232 comms chip. Interface to the display is here. Interface to the soundboard is here, and the rotary encoder for changing the channel, making it tunable, sits there. And I'm just working on this keypad. Bought these surplus at a very good price, nice chunky keypad, and that will sit in that housing, as you can see. And my little bit of the project was to mill the housing, and that's what it will look like when it's running, where the tuning encoder will sit here, and then we'll have a volume and squelch in the other two holes. So hopefully I'll show you that when it's fully put together and working. And yeah, 2012 I did that. If you want to see the milling machine, I converted a Tom Senior milling machine to CNC, and I did this on the Tom Senior milling machine, which I didn't bring to New Zealand because it weighed more than the bloody car. So I sold that off, and I built a lightweight CNC here, which I've never been quite as happy with as the old industrial machine. I don't think you can beat modifying a big heavy industrial machine for accuracy and rigidity. But if you do want to see that, if you go to YouTube and put my UK call sign in, which is Golf 4 Papa Mike Yankee, then you'll see that this casting being milled, and that was about 9 years ago. So yeah, it's taken a while to get round to it, as they say, and I'll update this video when it's built in. So, by way of a quick progress report, We've got the keypad connected now to the microprocessor, and we've got the serial lead on to the receiver, and we've also put on a little rotary encoder for tuning. Now the receiver must be on before you turn this controller on, because the first thing the controller does is to try and talk to the receiver. So I'm going to turn it on now. And there you see, it might be hard to see, let me just try and cover that up. So the receiver is set on 88 megahertz FM. The bandwidth is 3 kilohertz at the moment. We've got a 0.1 kilohertz step. We've got AGC is set to medium, the squelch is off, the gain is set to auto, and if I rotate the little encoder now, you can see that that's tuning. There's no aerial attached yet at the moment. Now one problem we do have is that this row, which is column 1 of the keypad, isn't producing any numbers. You'll notice if I press the frequency, see it says frequency there, if I press that, then the frequency goes to 0, and if I try and put in 3, 2 and then 1, nothing happens from the 1. And if I press enter, then 32 megs becomes the frequency that's in there. We also have a mode key here, mode. If you watch the FM, it becomes highlighted, and then using the tuning wheel, the encoder, you see you've got lower sideband, you've got upper sideband, CW, AM, FM, etc, etc. So that's what that does. Leave it in SSB mode. USB it's in. We've also got an AF level for the electronic volume control, which is here, which is not actually connected yet. So what I need to do now is fault find that column 1, and I'm pretty sure it's the actual processor that's got a fault on it. It's not code. Yeah, what I'm going to try and do is to get the hex code out of the processor using PickKit, and then I've got that on reserve, and see where we go from there. Thanks for watching. Hi, it's Joe here, just to catch up with the Vixen receiver. So another day, nearly 2 days writing pick code again and solving a hardware problem. So the basic elements are the Vixen receiver uses RS-232 to communicate, and you can set obviously frequency, demodulation mode, AGC, audio bandwidth, RF step, all the things that you would normally have on a good quality receiver. So the implementation here, we've got a 16F877 microprocessor, a PIC chip, which is looking at the keypad and also driving the display. It's mounted on the back of the display, you can see the display there, as well as RS-232 comms and a rotary encoder. So that's the basic elements. It's also got control here for the audio board, which I think I showed you before, but it's here. But I've not had a chance to do that with solving the little problems we had with the code. But if we turn that over, so try not to get in the right, very difficult in here, but in the top here you got the frequency, so it's on 157.325 at the moment. It's in FM mode. It's got a channel step of 12.5 kilohertz. It's got an audio bandwidth of 3. It's got medium AGC. The squelch is set at 0, and the automatic gain is set to automatic. So I just turn the volume up on the monitor, and we'll dial in a frequency. So you hit the frequency button here, and the frequency display goes to 0. We're going to dial in 161.575 and press enter. That's the weather service. Using the rotary encoder, if you watch it'll step at 12.5 kilohertz steps, which is what we set it to. If we press the mode button, if you watch the FM, so we're pressing mode, and you can see the cursors there, and we go to FSK, CW, AM, lower sideband, upper sideband, oh sorry, independent sideband, and back to FM. I think there is a lower sideband in there as well. There's USB. Yeah, there you go. And you just exit that mode, leave it in LSB mode, and then you can go to, if you press mode key more than once, so that's the mode. Now it's gone down to the audio bandwidth, and we can narrow that right down for CW. 300 Hz, 1.2K, 3K, 7.5K, 30K, up to 1.1 megahertz, which is for the video side of the receiver. So we'll go back to 3 kilohertz, press the mode key again, and it's gone on to the channel step. So we can change the channel step now to 25K or 100 Hz, 10 Hz, 100 Hz, etc. 9 kilohertz. I think there's an 8 in there as well. Yeah, so we're quite happy with the controller now. That seems to be working. So the next step is to get on with the audio interface, and finally try and backlight that display. I'm not sure if it's backlit or not. I'll have to get the data sheet out. But there you go. That's just where we are at the moment. So, taking a general look at the box, we've got a 4x4 keypad with the A key is frequency, B key is mode, C key is exit, D key is AF level, and the hash key is enter. The display, we've got frequency in the top corner, the mode of operation, the tuning step, the audio bandwidth, the squelch setting, the speed of the AGC, and the RF gain, which is set to auto. And if we press the frequency mode, you'll see the keys gone blank, and then we can enter a frequency using the keys and the enter key. If I press the mode key, you see the mode is illuminated, or it's highlighted, and then rotating the rotary control, we can go to ISB, FM, FSK, CW, AM, and USB. Let's go back to FM if I can, trying to do it holding it in my hand. If we press the mode key a second time, it goes to the audio bandwidth, and there we have a range of bandwidths up to 1.1 megahertz of IF bandwidth. That's for its video mode if it's enabled. We'll go back to 3K, press the mode key again, and it goes to the tuning step. This is when you're rotating the tuning control, and that's got a number of values in: 1k, 9k, 10k, 12.5k, 25k, and then back to the 10 Hertz. Press the mode key again, and we can set the AGC, which I won't change. I'll press the exit key, silly me. Back round. There's the error gain, set it auto. Now the AF, because this is capable of ISB, it has two audio outputs, this receiver. So there we're on audio output 1. We can rotate the control, go to 2, or we can go to 1 and 2 for ISB mode. Again, we'll leave it there. And finally the squelch, we can set the squelch, which I won't bother doing, and then back to the mode. So that's basically how the box works. It's serial into the receiver at 19K6 baud, and you know, sadly we can't get the keyboard back illumination to work. It works, but it's taking about 600 milliamps, which is way too high, so I suspect there's a faulty diode in there somewhere. So that's it. That's a quick overview of the Vixen interface control box, which we've built as an alternative to the computer program that we wrote, which is detailed earlier. Thanks for watching.